Okay, the Chapter 10 test is going to happen tomorrow. And so we're going to be going over a problem here, just one that's got 3D, before we do a little quiz in class with you and your partner. And then the answer key is worked out really nicely. Shout out to Mr. Ludvigson for making this little practice quiz that we're going to take in a minute. All right, so for right now, I asked kids to figure out the angle of elevation at F. I'm going to draw it because it helps to me anyway to at least have the thing drawn. The angle of elevation at F, that was the only thing we had connected was right here. Okay, so that's that, and that implies this green right triangle. Must be the one you're working with, right? You can either have one side and one angle or two sides in the triangle to be able to figure this out. Was this one of the kinds where you ended up with a side and an angle, or was it the kind where you ended up with two sides? Two sides, that's correct. All right, well, we already have one of the sides, so that's not too tough. Hold on just a second here. We have this side is 8. So how do we get another side? Well, did you figure out that you could figure out the flagpole height? This right here? Because it's the same as the other flagpole height. And then you'll have two sides. As soon as I know that, let's say it turns out to be like, 16 feet or whatever, then I'll have two sides, and I can use tangent of theta would be, it's not 16, but we'll figure out what it is. All right, get the idea? That's the approach, is that we can find that other side. So if we can find that flagpole, it has to be the same as the other flagpole. So that's this one, and that must mean I might have given you enough info to get that flagpole. Yes, look at that. I've got the 5 and the 30, which are making this triangle. I'll make the black dotted lines here. This guy and this guy and this guy. That's a right triangle. I made it a little tilty by accident, but and who figured out how tall the flagpole was? Raise your hand if your group got that. All right, good. What did your group say?
29.58.
Anybody get about 29.6-ish? All right, good. And the rounding can always be weird, but if that's 29.6, then I get, if you use a slightly different number, you'd have a slightly different angle. 29.6 here then, because they're the same height. And then you use these two, and you go tan of theta, TOA, opposite, 29.6 over 8, and then you do inverse tan on both sides. We actually had done that before I said to. In other words, you already had the answer. What did you guys get? Anybody verify 74.9? Awesome, lots of hands. So 74.9 degrees was your target in this case. All right, now I want you to just chew on this one for a minute. I'm going to twist this a little bit, make it a little bit harder. If I tell you that these two flagpoles were 60 feet apart, does that seem reasonable from my drawing? Does it seem reasonable that those flagpoles at this distance here could be 60 feet? Or do you feel like that's going to screw up your scale? Okay, so you think they should be closer than 60 feet? Maybe 50 feet or 40 feet or something like that? Because I don't want to mess up your scales, all I'm saying. I'm going to pick a number here. What do you guys think? 40? 40 or 50? All right, let's use 50. If the distance between the two flagpoles, the straight line distance is 50, then here's my question. What's angle CEB? It'll take you a while to figure out exactly what I'm asking you. Try to find angle CEB. I'm going to get this S out of here because it stands for south and it might confuse you. Everything, all the numbers are still the same from the other problem. What's angle CEB? Of course, you're going to try to turn that into a right triangle somehow and then try to figure it out. I'm going to pause for a sec. Give this one a try. So the mission this time, find CEB. I'm going to draw it up here. I will use the bright green. So here's C to E, and then E to B. And then there's a triangle that completes it right there. Do you know any of the sides or any of the angles? Yes, you do know one of the sides. That was critical. You needed to know that that side right there was 5. It's still 5. Okay, the little side. So if that's 5, if we know one other side, which we do, it's not that complicated. The 50 just comes straight down. You've got to be able to see relationships like that. So then it's just, I got 2 of the angles, or say 2 of the sides, and then you just got to use, was it sine, cosine, or tangent to find this little angle here that goes from C to E to B, that little angle there, I have its opposite and its adjacent. So that's tangent again. Tangent of some angle is 5 over 50. You do inverse tan on both sides. Inverse tan of 5/50. Who's actually got that answer as a decimal? Yes. 5.71 degrees. Let's call it 5.7 degrees. Raise your hand if you got about 5.7 degrees. Awesome. Okay. Next, this is a little bit strange, but if a person were going to go from point E to point C, what bearing could you tell them to take? To go from E to C, C, what is the bearing from E to C? You got to go to those compass roses now. Remember, 0 degrees would be north. Would be your bearing. You go from E to C. So we're all on the same page. That was north. This was north, just so we're all on the same page here. South was these guys. Remember, that was south, and that was south. I erased them to not confuse you with A, B, C, and D and stuff.
Can we define our own compass?
Can you make your own compass? No. Okay. Now, this little piece of advice might help some of you. This drawing has become so messy that if you have to, you should blow up the region in question. I'm going to take this and just go over here and make a new north, south, east, west for it, like I was looking down the bird's eye view on it. You know, north, south, west, east. And can you see that this has to go 90, and I'm still not there yet, plus another 90, and I'm still not there yet. See what I'm saying? And then it's coming out in between the next two, so it's coming out kind of like this in that direction. That's this line right here to get from E to C. All right, and it's how much more past these two 90s is it? So then we're trying to figure out this little angle right here. I am not sure I gave you enough information to do it. As I'm looking at it now, I thought I had it dialed in that my 5.7 degrees was this part, but I'm no longer confident that it is. I don't think it is. Do you guys agree that that's not actually where the 5.7 is? All right. All right, in my first class, I think I asked you something I didn't give you enough information for. I thought if this was 5.7, oh, then the kids will be able to just go, this one's 90 except minus 5.7. That's what I was expecting you to do, is 90 plus another 90, but then subtract the 5.7. But I don't think that's actually where that 5.7 is. So it might be able to be done, but I can tell you this, we're not going to beat this dead horse any further. We're going to move on to a different quiz, which is going to be given on paper in just a minute. It's going to be strange from this perspective. I'm not going to take the time to go over the quiz with you in class, but there's a key and it's already posted on Schoology, so you'll bring it home, and your homework for tonight will be to look that little practice quiz over, compare it to the key, try to figure out what's going on there. All right, before you put all your stuff away, I have one more question I want to ask that's not on the quiz because I know it's important. Do you remember the kind where you look up? Let's say that this is the height of the commons. You could stand in the commons, look up at a spot that's on the ceiling, and figure out the angle between you and that spot. Use your iPhone and like sight down there and say, oh, judging by my height, let's say, just to keep life simple, that you are your eyeballs technically are 6 feet off the ground. Okay. Do you get, if you knew this distance from you to underneath that thing, let's say you're looking at a sprinkler head up there or something, okay? If you knew this distance, it'd be incredibly easy. If this is like 28 degrees, and then this distance, if you knew this distance, it was like 50 feet, you'd be able to tell how high the commons was. You know what I'm saying? You just have to know how far is it to right underneath the sprinkler, and then you'd have one side, one angle, and it would not be hard at all to tell what the height was. You know what I'm saying? Okay. But what if you don't have time to measure out that distance here, the 50, so you just you go about 10 feet this way, and then you resight, and now it's a 40-degree angle. That's all you need to be able to tell me how tall the commons is. Set it up. Even if you don't finish it, set it up. 2 equations. Hopefully it's easy for you. Tell me how you would find h. I'll pause for a second when you give that a try. Okay, one note. I had the kids work on a couple practice problems on what's called the 10.2, 10.3 quiz. And I gave them the key to check it out. But there's one thing I would have done a little differently on the key. The wording was a little bit funny on which direction you wanted to go the bearing from. And we decided that the way the key did it was to go from here, wherever he is, to home. Okay, so and if you thought it was going the other way, I don't blame you. I thought it was not worded terribly well to make it clear. Okay, and then the last thing is they have all of these ways of writing the bearings. And if you do it in true bearings, it would have been 90 plus 90 plus 90 plus this last little one, which was 22. And so 90 plus 90 plus 90 is 90 times 3 is 270 plus 22 makes 292. And it could have 0.11 if you want to round the same way they did. All right, so 292 is a good way to do it if you want to do true bearings. All right, just wanted to clarify that one thing about one of those homework quiz questions.